Alright guys, this is my garage because my parents are sleeping, and this is my instructional video over topics that we learned in 7th period chemistry class over the course of the year. Matt Sheldon will be teaching you acids and bases, Ting and Denny with pH scale, Duncan Smith, bonding of atoms, and Joe Lackey with solubility. So I'm going to start off with what are acids and bases. Acids and bases are compounds that are measured on the pH scale, that is from 0 to 14. The pH scale is the potential hydrogen scale, which tells the concentration of hydrogen in the solution. Acids usually range from 0 to 7, while bases range from 7 to 14. Acids usually taste pretty sour, which is why I got soda. It's 3. Not really sour, but you know. That's nice. Now we got bleach, which is like a good 13 base, which tastes pretty bitter. Yeah, that's bitter. And we got urine for neutral, which is at 7, so we're going to see how this tastes. That's not bad. Alright. So why is soda considered an acid? It's because this compound produces more hydrolirium ions, also known as H positive, when it's dissolved. And because bleach is a base, this compound produces more hydroxide ions, also known as OH negative. If a solution has more H positive ions than OH negative ions, then the solution is an acid, and vice versa. This is how you can tell if a solution is an acid or it's a base. Now Tegan will take it away with the HP scale.
pH scale. pH scale classifies how acidic or basic a solution is. pH scale goes from 0 all the way to 14. The more acidic a basic solution is, it would range from 0 to 7, and all basic solutions range from 7 to 14 on the pH scale. A solution right at 7 would be classified as a neutral solution. The more acidic a solution is, the closer it is to 0. The more acidic a solution is, the closer it is to 14. The most basic solution is at 14. Hydrochloric acid is one of the most acidic solutions at HCl, and it's right at 0. And one of the most basic solutions would be hydroxide, which is NaOH. And then the most neutral solution would be water, which is H2O, which is right at 7. And so again, the most acidic solution is at 0, the most basic is at 14, and the neutral is at 7.
Today, we're going to talk about bonding. There are 2 types of bonds, covalent and ionic. First, we're going to talk about covalent bonds. Covalent bonds share electrons between nonmetals. The hydrogen and oxygen are sharing electrons to fill their outer shell. Oxygen has 6 valence electrons and hydrogen has 1. 8 electrons are required to make it complete. Therefore, 2 hydrogen atoms are required, which makes H2O, water. Oxygen needed 2 more electrons, so the 2 hydrogen atoms complete it. This is covalent bonding. Now we're going to talk about ionic bonds. Ionic bonds take electrons from one atom and give them to another. Chlorine has 7 electrons, so sodium's electron is taken and given to chlorine. This creates salt. Now the substance is balanced, leaving sodium with a positive charge and chlorine with a negative charge. These are covalent and ionic.
Alright, hi guys. Today we're going to talk about solubility. Solubility is the ability of a substance to be dissolved. As you can see here, we have sugar in the water, and that's been able to dissolve. That's an example of a soluble substance. Now something that can't be dissolved is known as insoluble. Right here you have sand that has not been dissolved. You can tell because it's sitting at the bottom, and it's still solid. Alright, now there are three key parts when a substance is dissolved. Don't know how to talk. Okay, there's a solute, and the solute is what is dissolved. And that'd be the sugar right here. And there's the solvent, which is the water. Alright, right here you can see the solute, and you have the solvent, and you mix them in. And when you do that, you create the third part, which is the solution. Alright, and that's when you mix the solute and the solvent together. Alright, now as the solute is added to a solvent, it goes through three key stages. It goes through unsaturated, which is when the solvent can hold more solute. Saturated, when the solvent can't hold any more of the solvent or the solute. And supersaturated, which is when the solvent has more solute than it can dissolve. And a solid begins to form at the bottom. And you can see that under. Okay? And right now, what you're looking at is the solubility curve. And it's a graph which shows how much is unsaturated, supersaturated, and saturated. The black line represents saturated, the blue represents supersaturated, and the red represents unsaturated. Now when it has more solute, it's obviously under. You know, because it has more solvent. It's obviously under because there's less solute. When there's more solute, it's over, and it's supersaturated. Alright, that's it.